Hello everyone, this is Durga Sai. We are carrying a major project in CSE stream. The title of the project is Early Detection of Stress in Paddy Crops Using Deep Learning Techniques. My teammates are Mohan Krishna and Sai Adithya. This is the certification page, and our supervisor is Dr.Rajeev Kumar. And this is the declaration page. This is the approval sheet, acknowledgement. In the abstract, coming to the abstract, this project is mainly based on the deep learning. We use the CNN, that is a convolutional neural network. Coming to the introduction part, stresses in paddy are common and they are facing a worldwide problem. Paddy is the most growing crop in the India. People in India mainly eat rice. So this is the stresses in paddy identification is most important. So in order to detect the stresses, we are using convolutional neural network to detect the stresses in that occur in a paddy crop. The proposed method involves training a CNN and we are using deep convolutional neural networks. These show the impressive results. The model we use is VGC16. Here the 16 represents the number of layers that exist in the neural network. And the aim of the project is to demonstrate the potential of deep learning approaches in improving crop management and facilitating early detection of stress in crops for greater yield. And the domain is deep learning. The scope of the project stress detection in crops using deep learning. Identify the crop of interest and the type of stress to be detected, such as drought, nutrient deficiency, or disease. The diseases are identified and we provide a suitable which type of stress is being developed in the crop is identified. These are the references we have collected. These are the literature reviews given by the authors. The existing system, there are several existing systems to detect the stresses in paddy crops. They involve several steps, include data pre-processing, feature extraction, and classification. The others applied principal component analysis to reduce the dimensionality of the data. The others used and this is the proposed system for early detection of stress in crops using deep learning. We are using convolutional neural networks, a set of filters to learn the spatial features of the crop, which are then used to classify the images into stress and non-stress categories. There are categories which classify them as stresses and non-stresses. In detail, it can be termed as the stresses that are being developed are classified as one sector, and the good health or healthy condition plants are classified as another sector, and they are fed into the system, and then they are carried out to find the accuracy and result. Is the proposed cross entropy is used as the mathematical algorithm that are used to identify the values. Feasibility study of the project is supported by recent advances in deep learning and remote sensing technologies. Furthermore, remote sensing technologies such as multispectral and Hyperspectral imaging enable the capture of high resolution images of crops, which can be used to detect stress. In order to implement this, we faced several challenges, technical challenges. Those include selection of appropriate sensors and imaging platforms, development of image processing algorithms, the training of deep learning models, and the integration of the system with existing agricultural technologies. In summary, the proposed project for early detection of stress in crops using deep learning is technically feasible, but it requires addressing several technical challenges and considering ethical, social, and economical factors. And coming to the economic feasibility, uh, the use of deep learning models can help farmers identify crop stress in real time, allowing them to make timely and appropriate actions to mitigate crop damage and reduce losses. This can result in higher crop yields and improved quality. And this can reduce the cost of production and also minimize the negative impact of these treatments on the environment and the chemical treatments on the environment. Coming to the technical feasibility of early detection of stress in crops using deep learning, by the availability of the high resolution imaging technology, the effectiveness of deep learning models for future extraction and classification, the ability to learn from large scale data sets, and the availability of powerful computing resources and software frameworks. And social feasibility can be termed as can lead to increased crop yields and better quality produce, ensuring food security for a growing population. Overall, the social feasibility of early detection of stress in crops using deep learning is promising. System specification, there are two sections. One is hardware specification and other is software specification. And a hardware specification, these are the specifications that is a processor, hard disk, and RAM. And in software specification, the OS, the platform, the programming language, as well as the data set requirement. We collected the data from the Kaggle. It is almost 22,000 images we have collected from Kaggle. And standards and policies, data privacy and security. And ethical considerations and environmental regulations. The system should comply with environmental regulations. And this is the method. Coming to the methodologies, this is the architecture diagram. Initially, an input image will be fed into this, and the model identifies the type of stress. And actually, the system is fed with a number of different classifications of images. The stresses, the images which are affected by stress, and as well as the healthy, and an algorithm will be fed that is cross entropy is used earlier, and this model is used to find the performance evaluation. It will give the accuracy at the end. Design phase. This is the data flow diagram, activity diagram. Images will be uploaded and they will be processed. And this is the use case diagram. Coming to the algorithm, this is the algorithm we have used. We collected the images, we pre-processed them. We used the convolutional network to extract features from them. It consists of multiple convolutional layers. As we termed earlier, BATCH-62 represents 16 layers. We train the CNN, then the CNN is used to test support vector measure or other classifier to classify the stress level. We used SVM, and we given a certain number of epochs to find the accuracy. Coming to the model description, there are 4 phases in the model description. That is data acquisition, pre-processing, model development, training, and evaluation. Data acquisition can be termed as to get the data, to collect the images, as well as the data required to start the process. And the data pre-processing, we use techniques such as normalization, scaling, and image enhancement should be applied to make the data suitable for deep learning model development. Actually, the images can be given, one will be in a bigger size, another will be smaller size. So we scale them to a certain size and make them all equal. and then it is fed into the data model. Then model development, we use the model CN convolutional neural networks. A suitable architecture is given for stress detection, and there are a number of layers such as neurons in each layer. This is as neural network defines the uh, neural system of the human body. It represents the number of layers as can be termed as neurons. And the training, the data, the pre-processed data is fed into the model and into the system, into the machine. It is allowed to find a pattern based on the trained data. A loss function is used to measure the difference between the predicted output and the actual output. Backpropagation algorithm is used to update the weights of the model to minimize the loss function. Evaluation, then the trained model need to be checked whether it is giving an good performance or not. So in order to carry out that, we need to train the, we need to test the data with other data. The metrics such as accuracy, precision, recall, the score should be calculated to determine the effectiveness of the model. And these are calculated and to find the performance of the model. So the testing is done. Once the test is done, we need to deploy the model for practical applications. This can be used even for real time. The system should provide a user interface for visualization of the stress detection results. These are the steps to execute, to implement the project. Initial step is to collect the data, and the second step is to pre-process the data. That is image scaling. Everything comes in this space. Enhancement, data augmentation, by using a random transformations such as rotations, flips, and scaling. The data is augmented. Model selection, a certain model is need to be selected. Here we used convolutional neural networks. This is used for image classification tasks. This can extract features from images automatically. And next step is to train the model. The model is trained with the pre-processed data. Then it is need to be evaluated. That is, it need to be tested whether the model is working properly or not, whether it is giving accurate results or not. So in this phase, in this step, it is evaluated. And after evaluation, we find certain odds that need to be corrected. So when these odds are corrected, we'll optimize. So in our optimization step is done to bring out the best output, to bring out the best accuracy. So this can be done through a process of trial and error or using automated techniques such as grid search or random search. The next step is implementation and testing. These are the input images we have collected from the data source. The data set contains 24,000 images. The data set need to be downloaded from the Kaggle and it need to be uploaded in Google Drive. So once when the process is started in the Google Colab, the drive is mounted onto the Colab in order to use the data set. This is the output that is obtained. This is the graph that is obtained. The graph which is in the line which is in blue color is the training loss, and the line which is in orange, the graph which is in orange color is validation loss. Here the loss need to be reduced. We can see that the gradual decrease of the graph. These are the values that we obtained during the process. For each epoch, we will get a certain values. We took nearly 10 epochs, so and a learning rate of 0.01. Testing. This testing phase is an important step in developing a project to verify the entire functionality of the developed system. Testing is classified into three types. Initial one is unit testing, integration testing, and systems testing. Here, unit testing focuses verification effort on the smallest unit of software design, that is the module. This test focuses on each module individually. Uh, Each module is tested individually and the module interfaces are verified for the consistency with the design specification. Integration testing, all the models which are created earlier will be merged together and check whether the system is working properly or not. Whether the merged data is in this testing, we have verified the working of certain part of code where it determines whether a certain functionality of the developed system affects the working of another functionality. And coming to the system testing, the whole program or the whole code which we have developed need to be tested in this phase. And the system testing can be termed as a complete functionality testing, whether the input images being taken and the output being produced is working properly or not, is being accurate or not. We need to give the optimal performance. So in this system testing, it is done. It also ensures the efficiency of the developing project. Here we can check whether the project is giving the output according to our scope of the developing. Whether the output which is being given is accurate or not is to be tested in this phase. This testing can be done the system testing. Efficiency of the proposed system. In future, we can try with some more different optimizer so that we could know whether they could produce some more accuracy with them or not. We have used an optimizer called Adam optimizer. It would get a more accuracy. The efficiency of early detection of stress in crops using deep learning can be improved using high quality data, advanced feature extraction techniques, appropriate model selection, transfer learning, and real-time monitoring. These approaches can help in developing accurate and efficient deep learning models for detecting stress in crops without plagiarism. And coming to the existing system, there are several existing systems for detecting the stress in crops and paddy. We have taken an example which is proposed by Mr. Wang et al. In 2019, which uses hyperspectral image classification for crop stress detection based on deep learning framework. The system involves several steps, including data pre-processing, feature extraction, and classification. The authors first collected hyperspectral images of crops and extracted the spectral reflectance values. And the authors applied principal component analysis. And they also use deep residual network with 50 layers, which has been shown to perform well or image classification. And coming to the proposed system, it is a DNN algorithm. DNN can be termed as deep neural networks. This is also the convolutional neural networks, filters, trained data set, and decision support system. Convolutional neural networks are a type of neural network, and this is the sample code. We have these are the values which are obtained as output, and the graph which is in blue can be termed as the training accuracy, and the graph which is in orange is validation accuracy. These are the enhancements. Coming to the conclusion, we have done this project with 3 to 4 months. A fully optimized model for early detection of stress in crops should be developed at the end of the project. Future enhancements, the development of new deep learning techniques, architecture specifically designed for crop stress detection could also improve the accuracy and speed of detection. We have used convolutional neural networks in similar way, and the domain-specific knowledge and expertise into the development of deep learning models could help ensure the models are effective and practical for use in the field. These are the industry details, but it is not started. This is the plagiarism report. Coming to the source code and poster presentation, this is the source code we have used. This is the poster we have done. These are the references according to IEEE format. We have collected up to 20 references. Coming to the implementation part, the initial part is to mount the drive. So initial cell will be used to mount the drive. As the data is uploaded in the Google Drive, we need to mount the drive through Colab. so that we can use the data from drive. And this is the TensorFlow, the library which is used. And Keras is also the library which is used to carry out the. These libraries are generally used to handle with data sets. The image sizes are given, and the training path and validation path is given. Inception is another one more library which is used with ImageNet. These are the and globe variable is used to find specific patterns in the data set which are used. This is the model summary. And from TensorFlow, we use the imported Keras, and the learning rate is given as 0.1. TensorFlow, the pre-processing step is done. These are the rescaling of the image is given. Shear range, zoom range, horizontal flip, everything is given. The rescale size is given as 1 by 225. And the training set is we obtain this from the drive. The target size is given and the batch size is given. We need to classify them, so it is given as categorical class. In this step, when images are uploaded from the classes, it will be said that it will be displayed how many images are taken and how many it belongs to how many classes. And this is the testing set. It will be showing the batch size all thing. These are the number of epochs we have given. We have given up to 10 epochs. This is the data set. Validation is done here. These are the values we have obtained when we run this code. These are the values up to 10 epochs. These are the accuracy. The accuracy is 0.8 something. These are the values we have obtained in them. This is the plotting of the graph. This is the code related to the plotting. Initial one is training loss and validation loss, and the second slot becomes valid accuracy. The values belong to accuracy. These are the output images we have obtained when the graph is plotted and we run the code. According to the values, we have obtained these graphs. Thank you.